Scalar quantities have a value with no direction in space, such as a time period of 3 seconds, whereas vector quantities have a value with a specific direction in space, such as 2.5 kilometers eastward. Some examples of scalar quantities are length, mass, time, temperature, volume, energy, and power. Some examples of vector quantities are force, displacement, velocity, momentum, acceleration, moment, and stress. A vector is represented visually or graphically by an arrow, shown here. The length of the arrow represents the magnitude or size of the vector, and the angle theta defines its direction. Point O lies at the tail of the vector, and point P lies at the head of the vector. So each vector has a head and a tail. The line of action is the line along which the vector lies. In print only, vectors are represented by bold-faced letters. When referring only to the magnitude of the vector, however, italics, not bold, is used. Thus, we refer to the vector as bolded A in print, and its scalar magnitude, or simply its size, as italicized A. For handwritten work, however, it is required to use the proper vector arrow symbol. Vector operations, we have multiplication or division by a scalar. In this case, when we multiply or divide a vector by a scalar, the line of action of the vector is preserved. The magnitude of the vector changes, it scales up or down, and the direction may be reversed. It's only reversed if we are multiplying or dividing by a negative scalar. So this is vector A, in this direction, this magnitude. Vector 2A is that vector A doubled in size in the same direction. Vector negative A, which is negative 1 times A, is the same size or magnitude with a swapped direction due to the negative sign. And negative 0.5A vector has the opposite direction of this vector A and is now cut in half.